I am Abdul Chatterjee. It's your third lesson related to the topic matrix. Today we will discuss about the elementary row operations in matrices, equivalent matrices, invertible matrices, and to find the multiplicative inverse of a non-singular matrix using elementary row operations. And we will also discuss some related problems. Now, what is elementary operations? In matrix, there are three elementary operations, elementary row operations or elementary column operations, but here we will discuss about elementary row operations. The first operations is to interchange between any two rows. Suppose two rows, ith and jth row, you can interchange them. After interchanging, the matrix formed is called equivalent matrix to the original one. Here an example is given. The matrix E, first row is 2, 3, 5, 7, minus 9, 1, 6, 4, minus 6, and we are applying R1 and R2 interchanged. So we will write the operations in this way, and the equivalent matrix formed will be 7 minus 9 1, 2 3 5, 6 4 minus 6. The second operations, elementary operations, is multiplication of a row by a non-zero constant. Suppose if you wish to multiply a particular row of a matrix by 3, then here you will write, suppose R2 you wish to change, R2 is converted to 3R2. Here the left hand side gives you the new second row and the right hand side gives you the 3 times the old one. So the new matrix formed is 2, 3, 5, 21 minus 27, 3 and 6, 4 minus 6. The third elementary row operations is the constant multiple of a particular row you can add to any other row. Suppose jth row is multiplied by k and added to ith row. So we will write the new ith row is previous one, the previous ith row plus k times the jth row. An example is given here. Here the new third row is previous one, previous third row minus 3 into first row. Here constant is k is minus 3. So these three elementary row operations are there. First one, interchanging any two rows. Second one, multiplication of a particular row by a non-zero constant. And the third one is a constant multiple of a particular row you are adding to any other row. Now what's the use of this? We know the inverse of a real number with respect to multiplication or addition, etc. Here in multiplication, matrix multiplication, we can find out the inverse of a matrix. That is called multiplicative inverse of a matrix. Let A be a square matrix of order n by n and B is another square matrix of the same order n by n. And if it satisfies that AB is equal to BA is equal to identity matrix of order n, then you can say A and B are inverse to each other. That is, A inverse is equal to B, or you can also say B inverse is equal to A. An example here given, A and B, two matrices, and after multiplication you are getting the identity matrix. And so you can say these are inverse to each other. Now using elementary row transformation or elementary row operations, we will find out the multiplicative inverse of a non-singular matrix. Non-singular matrix we will discuss in the chapter determinant, the matrix in which determinant value is non-zero, that is called non-singular matrix. We will discuss later on, but here what the steps are to find out the inverse of a matrix. The first step, you should write the matrix A, whose inverse to be derived. A is equal to identity matrix into A of the same order. Now, second step, use elementary operations on both sides and convert the matrix A, left hand side, into a unit matrix, into an unit matrix. Then same operation will be applied on the right hand side on the matrix, identity matrix I. Corresponding change, suppose finally it changed to B. So ultimately you will get I is equal to B into A. Then you can say the inverse of A is equal to the matrix B. An example is given here of order 2 by 2. Suppose A is equal to 6, 7, 8, 9. First row 6, 7, second row 8 and 9. You have to find the inverse of this matrix using elementary row operations. There is a shortcut technique to understand it. There are 4 steps. For 2 by 2 matrix, 4 steps sufficient. First step, make the element 1, 1 element as 1. And corresponding operation you will apply. The second step, using that row, convert the element just below it, that is A21, 0. The third step, convert the element A22, that is diagonal element, again convert it into 1 using elementary operations. And using this one, convert that element A12 into 0. So 4 steps. So first step, we will convert this element 6 into 1 using elementary operation. So easiest application is if I multiply the first row by 1 by 6. The new first row is 1 by 6 of the row 1, old R1. So it is 1, 7 by 6 and remaining rows unaltered, 8, 9. And same operation applied on the right hand side identity matrix is 1 by 6, 0, and second row as it is 0, 1, and A is as it is. Now the second step I told, convert the element A21 into 0 using the first row. So if I operate in this way, R2 is R2 minus 8R1, that is first row is multiplied by 8 and subtracted from second row. So the new matrix formed will be 7 by 6, 0 minus 1 by 3, and the matrix on the right hand side will be 1 by 6, 0 minus 4 by 3, 1 into A. So using the first row, we convert the second row in such a way that the element A21 is 0. The third step, I told, convert the diagonal element, another diagonal element 1 using suitable operation. So here it is minus 1 by 3. If I multiply it by minus 3, that will be 1. So R2 is multiplied by minus 3. So the new matrix on the left hand side is 1, 7 by 6, 0, 1. And right hand side, here it is 1 by 6 and 0 as it is. And the second row is 4, 4 and minus 3. The final steps is convert this element A21, 0 using the second row. So if I multiply the second row by 7 by 6 and subtract from the first row, we will get our desired. So the new matrix formed is 1, 0, 0, 1 left hand side, and corresponding operations on the right hand side gives you minus 9 by 2, 7 by 2, 4 minus 3 into A. So I is equal to B into A, where B is equal to minus 9 by 2, 7 by 2, 4 minus 3. If you take common 1 by 2, that is minus 9, 7, 8, minus 6. So here it is, A inverse is equal to B is equal to half of minus 9, 7, 8, minus 6.